Okay, so welcome to the online lecture and first recording of the seminar Security in P2P Systems. So unfortunately the meeting couldn't find place, so this recording should help to keep up the topics and to still have the meeting. So in this lecture and this overview, I will present you the organizational overview, I will present the topics and the tools that we use, and give you the timeline basically for the seminar. So first we start with the organizational issues. So you find the security seminar in Paul under this information. So important here is that you can use it in the modules MUA, algorithm and networks, and in ESS, Rechnernetze. So you have the opportunity to get to have it counted for both, but you should still consider that for both aspects, both modules, there are different topics to reflect this choice. These tools should be used, so everything that I say you find also on the website. That's an important access point for the seminar, so the website's links is given at the top. And we will use EasyChair, that's an online management tool for seminars and for conferences, to upload the papers and to review them. So here's the link. And we use for some parts of and some topics we use the simulator pfxsim.com, the University of Paderborn fork. So if you visit the website, you'll find the code and documentation. But we will also have 2 lectures in the seminar to introduce you enough in the topic so that you don't have to, because it's all covering the same topic somehow in the seminar, and you should be up to date, and also how to use the simulator if you need it. And what I also want to give you at hand is this doodle for the topic selection. So today I will present you the topics that are available in the seminar, and you have the opportunity, and you should make a choice until next week. Okay, so the schedule considers the following dates. So today should have been presented, and at least it's online, the organizational details and the presentation of the topics. And time for questions is probably not the best to list here, but I think you still can write me emails, and we will have this time for questions next week. Until next week, you should choose the seminar topics according, again, this doodle link. And next week we meet again. We meet, and hopefully this time it takes place. So check Paul for when it will take place, and it will be according to that. And the topic assignment will be announced, and there's time for questions. And it's also the first introductory lecture, so that everybody gets the basis knowledge that is required. Okay, the seminar schedule further continues. So in May and of course also in April and May and June, you have time to work on the topic and to elaborate on the questions. And if you have any question, write me an email. You could also schedule a meeting via email, and there will be also a doodle for so there are 10 topics which are covering the simulator and using a simulator. So there will be weekly meetings where you have the opportunity to ask questions, and it will be also announced next week when is the best date. But important, there's also a doodle where you can note when in the week you have time and when you would like to meet. It's probably for those people who have a topic of simulator related. Okay, so from the timeline, what follows next is on 10th of June. You have then already anyway your topic, and you have prepared your paper up to a list, and then 10th of June you should register your paper in EasyChair, so the conference management tool. And on 17th of June you should bid for papers that you would like to review, so you are also reviewer. And bidding means you say what you like to read. Then 24th of June, shortly before midnight, you should submit your seminar paper, and the day after you receive 3 seminar papers to review. 1 week later, on 1st of July, you should submit your 3 reviews to the seminar papers you got, and send me via email your presentation slides. Then you get during this also feedback, so both from the reviews that you receive, but I will also give you some feedback for your presentations, and until the 8th of July you should include the feedback for your from your reviews for the presentation slides, and to have everything final and submitted at that day. And on 12th and 13th of July we will have a blog seminar with presentations from, we will see, probably it's also less, and it's not taking 2 days. We will see which room we get and how much time we will need. So this is still pending, but just to make sure that these days are saved for that. Okay, how should it look like? So the presentation of the papers that you should write in the seminar is also all the templates are given, so it's an 8+ pages according to this template. You should use this template, and it's on the website. It's an IEEE transaction style, and the presentation will cover 25 minutes talk and 5 minutes of discussion, probably 10 minutes, and also for that you get template. And what's important for the grading, I think I also have a specific single slide on that. Yes, just make sure every submission that you do counts. So that means that the first version of the paper before the review, so for reviewing, is already important. So try to make it as best as you can. Of course, the final version of the paper, seminar paper, also counts, so how you included the feedback. And what's important, so scientific content, so how well you wrote it and how much it's included what you should have answered, also how you wrote it. Then the second part is the review quality. So you will have to do a review, and the question is, how much effort did you put to give valuable feedback, how detailed you read the paper, and really tried to give as much to the authors as you can. So best to do there is to be detailed, to be specific, to invest a good time to improve the papers of others. And in the presentation that you give, of course, the content, and also how well you stick to the time, and how well you can present your results in a given time frame. Okay, so this is the organizational aspect. So from the time plan, what I want to present now is paper details. So when writing the paper, what you should look at. Of course, you wrote already your bachelor thesis. I still want to, and you know how to structure probably a paper, although I would also like to give you some hints how to do it good. But something that's important I want to present on the next slides. So first of all, from the last seminar and also from previous seminars, it was the observation that the language should be really made very good, because it gives the first impression. If you have spelling mistakes, then people know you didn't put too much effort, and it's really degrading the quality of your paper. So use spell checkers, use a program. There are sufficiently many for it, and spell check also by humans. And I would also like to advise you to not just ask your close friends, probably also from the same cultural background or language background, because every language has its own specifica and the same mistakes that are done. So a German person typically uses long sentences, for example, or Slavic persons don't use articles. So, and if you stay in that, you ask somebody from the same language background to read your paper, they don't notice it. So best is to have somebody else, or to have a mixture and have several people reading your paper to make sure that the language is really good. Also the presentation, use scalable vector graphics. That means PDFs or encapsulated postscripts, and they are infinitely zoomable. That means, for example, on the picture on the top right, I cannot read what's written in on the little descriptions, and also the coordinates, and the legend is too small to read, so it's not really readable, and I cannot zoom in to see what's happening. So make sure that your graphics are scalable vector graphics, and the font sizes are also proper. Also be careful with colors. Best is to not use them. So here you see an example of a colorful picture, a figure that describes something, and if you print it, then it looks like here on the right, so you don't really see which graph is referring to what. So make sure that even if printed black and white, everything is well readable. Okay, something else that's also as important as spell checking is the correct citation. Visit this PDF, just download it. It's from the last seminar. It's also still valid, and you should apply it, because the important part of the references is that it looks consistent. So that means that if you look at the references at the end and they are full of spelling mistakes, they are full of inconsistent formatting, so large letters, small letters, it just looks like randomly put together and that you didn't put effort. So also the references should look like that you put effort. To give you some bad examples is, for example, here you see how to, on the right side you see how you should not do it. On the left side you see how you should do it. So for example, you should try to always abbreviate names. That means the first name. Here it's okay, so the first name is always abbreviated, but because typically you do not have always these first names. Also make sure that it's in the proper writing. So for example, in this part all the names are written in normal letters, here only capitalized letters, and here the order of the names is mixed. So this shouldn't be not done. Also with conference names, you should make sure that the numbering, I would skip them, because you either have them all and all equally, so or you don't have it at all. So for example here it's sometimes written, let me just see, the International Conference on Pervasive Computing, it's all written out, sometimes it's abbreviated. So here for example Infocom, it's even 3 times differently written, so capitalized, written out, or in small letters. Here also journal is once written out, then abbreviated, then only a J. So make sure to don't have it like this, but to have it always consistent. Also the order of the information, also make sure that you either have the year, so the year should be always be inside. Also decide whether you want to put in the specific publisher and that it's written, so ACM or IEEE. And I would delete the page numbers, the places, and the editors. So for example, nobody's really interested whether the conference was held in, let's see, here was an example. So for example, that was on June 22nd to 26th. That's not really relevant. It's also not relevant whether it's pages 1 to 6 or 7 to 8. That's also not so relevant to find it. And it's also not relevant that it was in Norwell, Massachusetts. So just to make sure that the information that you have for all entries and for all references, and to write them in the same way. So for example, here's a good example where everything looks the same, everything is consistently written, and it follows the same structure all over the whole references. Something extremely important, so this is really important to say, and I also will say it the next time. So the last time I had there were some issues with the seminar that were conducted. So just to name you some examples from the last project groups, there were in this field, we had 10 participants in the beginning and only 5 remained. So 5 failed in the seminar phase due to plagiarism. Also in the last peer-to-peer seminar, starting with 28 participants, 7 participants failed due to plagiarism. So this is a really extreme risk to fail, and to also fail the module with that, because the simple rule is, if you do plagiarism, then you will fail the course. So really make sure to know what plagiarism is. And in order to make it sure, I also have some examples. So what is plagiarism? Plagiarism is the copy and paste of text. So if you find some good results, some good text, some good description of an algorithm that you also would like to describe, and you just copy over the text, then you are already out. So you should not and must not take text of somebody else. If you some persons, they knew that they shouldn't copy text, so the idea was, okay, I find the text good, so I don't copy it like it is. I just change word or sentence by sentence, but still follow the same line of arguments like the source document, so just rewriting it a bit. Also, that is plagiarism and it's not allowed. So you must not follow other people's argumentation rule and just take it over. So you have to also think of your own, restructure the text of your own and write it your own. Also, what is not allowed is reusing figures without noting the source. So if you find a nice description of a nice picture to something and you take the figure but you do not say where you have it from, that's also not allowed. And so taking ideas and present as your own, I think it's not really fitting probably here, because the seminar itself is not like a master thesis or dissertation, but you should also take care where the ideas and can come from and who's the author of it. How is plagiarism detected? First of all, I have lots of experience with it, so I can detect it, and there are also tools like Docolog there where you can simply upload the documents and it's automatically checked with several sources of scientific documents to see whether there's some correlation. And the detection rate is really extremely high, and it's really simple to detect. So if you do plagiarism, you fail the course. So of course you want to know what's not plagiarism then, if everything seems to be so dramatic. First of all, to reference the source of the ideas. So this is again the case. If you have to invent something new, then you should, and if you take over some ideas, then of course you have to reference them. What's also not plagiarism is if you find some proper algorithm that's, for example, a plagiarizing person would copy or somebody would rewrite it. What's not allowed, but what is allowed is to take the protocol, read it, and or the algorithm, and put it aside, close it, and summarize it and present it with your own words, with your own thinking, with your own let's say argumentation and structure of arguments. And what should be also considered is to have, one moment. So what should be also considered is that what I recommend: read all material, close all sources, describe it with your own text structure and sentences, words and figures, do it all yourself. Of course you describe something that's existing, but do it with your own words, with your own arguments and with your own structured text. To give you some example, so for example, this is from some source where plagiarism was detected, and on the right side you see in red the exactly copied text, what was detected, the not underlined or not crossed out parts that are not plagiarized, but the red ones I've detected as plagiarism, and it was leading also to several consequences. Basically, so here algorithm was described, and the problem was really copying text from other text, and that was not acceptable. Another example, so on the right side, on the left side you see, for example, is a snapshot of somebody else's seminar paper, and on the right side it was the original text to it. So I detected this text, and it was simple to detect, and here you see what's also not allowed is to reuse the text structure. So on the left you see, so on the right is the original, and then on the left the student rewrote sentence by sentence to have the same statements, the same story, but with not copy and paste. So for example, on the left side it's written, once the connection has been established successfully, every communication between the servants is done via the so-called Nutella protocol descriptors, and the translation to it is, once the connection is established. So it's a present tense, successfully each and every communication between the peers are done through Nutella protocol descriptors. So very close. I mean, that's very obvious. That's the same sentence, and also if you go through the sentence by sentence, so here's a new sentence was introduced, but the next sentences are same, and then the following sentences are same. So just read, let's say translate it, or a little bit. It's more like a copy, merge, and paste. Also, this is definitely not allowed, and this also led to failing the seminar. So again, what is allowed? If you find something useful, something fitting, and you've liked the argumentation, then think about it, build your own argumentation line, close the source, don't look at it, write it with your own words, and then it will be your own statement. So very important, don't plagiarize. If you are unsure what is allowed or what not, ask in before submitting. As it was said, even the first submission before, so for getting the reviews is already counting. And especially in this case, so this person was submitting the paper in before, and he wanted to give the excuse, after the review I would have changed it, but this is not valid, so every submission counts and you shouldn't have plagiarism inside. So better to ask before, make sure that you are all correct, and then it's good. Okay, so which tools are used? Again, so of course the LaTeX, we use LaTeX, and there is a template for it to use to write the papers. I can recommend several LaTeX editors. I myself use Kyle under Linux. Technic Center for Windows also good. TechLibs plugin for Eclipse. So use what you would like to use. It doesn't matter. Just the results should be good, and it should be in LaTeX. Bibliography editors, there are several to recommend. Mendeley is quite interesting. So it's also a social network behind, and you can organize your data within. JabRef is a nice graphical user interface. I myself use a text editor. It gives still the most control, but important with bibliography, make sure that the references are consistent. Okay, coming to the EasyChair as a conference management tool. So as it was said, we will use EasyChair, and this is a website to organize the submissions of the papers and to collect the reviews and to give feedback. And I already invited all of you to EasyChair to become a reviewer. That's why you should also accept it. And you will have 2 roles in EasyChair, but only you will have these 2 roles, so author and reviewer, in the case that you use your email address for registration that you already posted in Paul. So in Paul, where your names and all your email addresses are listed for participating in the seminar. So if you create an account, then make sure, so for an account for an author, to become an author, make sure that you use your email address that you also had in Paul. So how does it look like? Here on the right side is a nice example. You will, if you log in, you will have basically in the beginning only the submissions, where you can submit a new paper, or you can go to the reviews, where you see such an overview, and you can give a review to the paper. So yeah, lots of terminology. So what's EasyChair? Web-based conference management system. You can submit a paper, you can bid for paper reviews. That means that you can choose what you would like to review. You can, of course, as a reviewer, access the papers you should review and submit your reviews. Register in EasyChair, yeah, it was like it was said, using the email address as in Paul. 1 student, 1 account. And for the case that you have 2 authors for a paper that's especially counting for the simulator papers, then of course both of them can edit the content and the submission. So you have 2 roles, author and program committee member. That means reviewer, and you can switch between them. Okay, once again, so in your role as an author, you can submit, the website is given. You can update it anytime until the deadline, and yeah, of course you can only submit as an author, not as a reviewer. So again, you have these different roles. So as an author, you register your paper to say to give the title and the abstract. As a reviewer, you will bid for the free papers that you would like to review. As an author, again, you will submit your paper. As a reviewer, again, you will have to submit your reviews. Approximately the next day, I think, you will, as an author, receive the reviews, and as an author, again, you will have to include the feedback and submit the final paper. So you see, you really need both of the roles, and it's really inconvenient if you have different logins for that. So use only one single email address for it, and then you are fine. Okay, so what do you have to do? So first of all, as an author, it was said you should submit and register, but anyway, you have to become a reviewer. You received an invitation via email to become PC Program Committee member, and you should accept it. And with that email address, again, you can also log in as an author or create an account. And for paper bidding, that's still a little bit far away, but you will have the choice between yes, maybe, no, or conflict. That means that's your best friend, for example, that you never want to review, to give him feedback because he wouldn't like you after that. So it's just a good option to make a choice what you would like to review. Anyway, there's a clever algorithm in EasyChair for an optimal review assignment, and that will be applied, and then that's the way how you get your reviews assigned. Of course, there's no guarantee that you get your preferences, but the optimal review assignment should be optimal and objective. Okay, reviewing as PC member, that means, so what will happen? So you will get 3 papers to review. You can go then to first, I jumped just to, where is it? Yeah, here it's how it looks like. So you can click then on reviews, and then under my papers, and add a review or read the papers and see what's going on. I mean, you are all studying computer science, and that should be doable by everybody. I also recommend to install a copy of the review on your machine. If I also had a case that once I wanted to upload the review and the internet connection was lost, and then the review was gone, and it's good to have the copy of the review before submitting. Okay, deadline for review submissions, the dates and the time, and it's German time, not the Pacific Western time. So that should be known. Also, if you once send a review, you can revise it until the deadline of the review. So but both of them and all reviews will always stay in the system, so that you cannot hide previous comments, for example. So make sure that also your review is very precise and good and well written and objective and gives proper feedback. Okay. So this is according for the tools that will be used to manage the seminar papers and the submissions and the reviews. Now I want to motivate the seminar topics that we have, and for that give a mini intro to peer-to-peer, chord, and pastry, because many topics are covering these 2 overlays, and of course they are all in the field of peer-to-peer. So, coming to peer-to-peer, so what is peer-to-peer and what should be known in order to get an understanding? So first of all, overlay networks. That's basically the basis of the main idea of peer-to-peer in such, because what's an overlay network? An overlay network is network on top of existing networks, and a subset of nodes of the underlying network create a new network on top. So that means you have several networks, and some nodes out of it create a new network on top of the previous networks, and this new network, this new overlay network, creates a new functionality. So it offers more than the layers and the networks below have offered. So for example, search for files, or multicast. That's even the most important, most prominent overlays that you have on application layer. multicast because the TCP/IP network doesn't support it, or anonymizing multi-hop routing like Tor, for example. That's also an overlay network where messages are transferred multi-hop before inserted into the internet. And the peer-to-peer overlay network, so that's has some specific characteristics. It's often very related to data, so content-centric. And what it offers, the main functionality, what it's used for, is content-centric routing. That means that you can find content, so you can store content in the network and find the content based on its information. So storage and retrieval, search, and such services are supported. So what are the characteristics of peer-to-peer? So what makes it special? So first of all, what makes peer-to-peer special is that you have all resources like storage space, computational power at private nodes. That means you cannot really take control on what they offer. It's uncontrollable, it's voluntarily offers, and you only get what they give. And the second point is it's also very heterogeneous. So bandwidth, CPU power, storage space, it's all depending on the nodes, and it's all different. So you have mobile nodes, you have tablets, you have desktop PCs, you have various capabilities, you have servers in the network. So first of all of the resources belong to users that you cannot control, and it's voluntarily offered, and it's very diverse. And third, it's very distributed locally, so all over the world. You don't know where it comes from, and that's all resulting basically in lots of uncertainty on what kind of resources you have at hand. With regard to the networks, the problem is that because these resources are in the hand of private devices and private peers, you have so-called churn and variable connectivity. Churn means basically dynamism. So nodes go online and offline as they wish. They only stay online for a limited time. It's very unpredictable how long they will stay online. So not just that the resources are very diverse and all voluntarily offered, they also are not reliable. So they go offline and the storage space is lost and the data on it is lost, so it has to be replicated. And to overcome this problem of offline nodes and variable connectivity, clever algorithms have to be applied. Point number 5 means if you have all of these resources offered by peers and by private persons, the offering and the serving of such content comes also together with using such services and some such resources. So the personal users and the peers in the network are both providing resources but also using it. So they're both servers and clients or servants in one. And in order to really use these resources, there are basically two aspects. So first, finding what you want, and second, the direct interaction of getting what you want from the specific peer that provides it. So this peer-to-peer communication. And referring to the point that finding what you are looking for that, number 8, you need a self-organizing system. That means the nodes have to organize them in a way that allow you to find what you're looking for, to allocate the resources, and to enable the search for such content or such resources in a decentralized manner, without centralized control, without centralized overview. And so all have to be done by the peers, and they are thus very autonomously, and they are very active in the network, and they are very needed. And so you see lots of dynamics, so you don't know what kind of resources you have. It's very diverse and it's not reliable, and the nodes go online and offline, and you still need the nodes to have them decentrally and self-organizingly active in the network to enable you to find what you're looking for. And of course you see also some opportunities, but there are also some problems. So one opportunity is, for example, to find data what you are looking for. So if you have here a little guy and he has some item D and he wants to store it somewhere in the network, and somebody else who's looking for it should also be able to find it. So the question is, so distributed indexing means that, for example, such an object can be stored somewhere, and the link, basically the information about where it is somehow managed by the network, so that if other nodes are looking for it, they can find it by asking the network. What is how it is done in peer-to-peer networks, so one of the main approaches is really to have responsibilities for objects and object IDs. So both the nodes and the objects are somehow having an ID. And this distributed indexing is solved often in distributed hash tables, where one node with a specific node identifier is responsible for a set of object IDs. That's quite efficient, so you can have a very small node state. That means O of log n, with n being the number of nodes in the network, and so connections, and it allows you to have a communication effort to find content that you are looking for, also in O log n hops, which is quite fast. So the network and this connection and overlay network of peers allows you to find and store content quite efficiently without too much overhead. One of the main examples there are basically, so this is the most prominent overlay distributed hash table in the scientific community. It's called CORD, and what it does, it uses for both the objects and the nodes a 106 object and node identifier. It's, for example, gotten from the IP address for the nodes, or the hash of the object name, or the object itself. And how is it then organized to find object that you're looking for? For that, CORD organizes the nodes in a ring which wraps around, so that you have really a circle. And each node keeps track of its predecessor and successor in the network, and it's responsible for all of the object IDs between its predecessor and itself. So there's a simple topology, there's a responsibility for objects, and in order to improve the search abilities for content, you also have so-called fingers, which are shortcuts in the network, which allow you to, so if you have O log n fingers, it also allows you to have a lookup operation of O log n length. So to give you an example, so here you see the ring, and for the node 3485, you have the responsibility area depicted red, so from the predecessor plus 1, so 2907, to the node ID of the peer. So this is the responsibility, and all of the objects that have this object ID listed here will be put there basically, and everybody who is looking for an object with an ID in this area is also contacting this node. And so how is this contacting and routing done? So first of all, every node, as it was shown, has a contact to its predecessor. So 709, for example, has a contact to its predecessor 659, and to its successor, and also this so-called fingers, which are shortcuts in the network, and basically enable to encode its the links are established like this, so in exponential distance, and it just allows you to, if you have anywhere an object ID that you're looking for, with every step and hop in using a finger, you halve the distance to that object. Okay, and a simple example how a lookup looks like. So here node 1008 queries the item 3000, so it uses its first finger, which is 2032, and for that this node 2207 is responsible, and that one uses its finger and it jumps to this node 2906, and it uses its next finger, and it's also detecting, oh, it's my predecessor, my successor, who's responsible for it, because between us there's no other node which has a bigger ID. So the object ID is found, and it's very convenient, and we have it in O log n steps found. Okay. Coming to pastry, it's a very short overview now. This is also a very relevant one because it's quite frequently used in scientific communities if you have a prototype or something scientific prototype basically. And the idea is that it's very simple. It's also DHT with prefix-based routing, and there's a prototypical implementation of pastry called FreePastry, which is very used in the scientific community. It's also very important. It has lots of extensions like replication layer, for example. And this prefix-based routing is similar to DNS. So you approach the object ID digit by digit, so you increase the matching prefix basically until you find a node which doesn't have further context to come closer to that node, to that object that you're looking for. So that node is responsible. And for that you have a routing table. So I just want to give you a short example how it looks like, because many topics of the seminar also relate to it. So the routing table helps you basically to resolve this prefix-based routing, and what you also have beside the routing table is a leaf set, closest neighbors, so that you know really the nodes in your numerical neighborhood to know for which objects you are responsible for, and the neighborhood set with locally close nodes or geographically close nodes. So let's have an example. So here we see the routing table of a pastry node. The node ID is 102.33102, so there are 4 digits, so ranging from 0 to 3. And we see here on the right side the routing table that is in this node, its leaf set. So these are the most closest numerical IDs that are known, so the most closest nodes that are in the network. And if we get a message, for example, routed to the ID K, then we go through the routing table like this. So first of all, we check whether K is in the scope of our leaf set. So we find, so for example, if K is very close to ours, but there's a closer one in our leaf set, we forward it directly. In the second case, we have it if it's not in the leaf set, but we have an entry in the routing table. So for example, K is like this, so 01320 and so on, and we see the prefix that's matching is 10. So we look in the third row, so that means we have a prefix match of 2. And we are looking for the entry, the next one should be a 3. So this is the entry where we have a node sitting in and placed, and this is also the node where we forward the message to. For the cases when we don't have any entry, and this is for example if K is so close to us that we have a very long prefix, so in this case the prefix is matching in 5 digits, and this is over here, and we don't have an entry for the, let me just see, for this one. So we pick the closest node in our routing table that is still fitting. So this would be that one. Okay, yeah, because we didn't have an entry over here. And in the case that there is that we are already the closest, even in comparison to our leaf set nodes, then we are responsible for it. So this is how routing in FreePastry and Pastry works. And of course, there are several problems. First of all, because it is peer-to-peer based and routing is in the hand of the user devices, routing can be also forged and attacked by these devices. So we have routing attacks in the case that we have malicious nodes in the network. They can attack this. So what can happen? So for example, the attacker can forward messages incorrectly. So either he can drop them at all or to send them in the wrong direction. That means using the routing procedure to extend the length of the route. Of course, the querying node and the node interested in the results should check this somehow. What could also be happening is that the attacker claims to a wrong node to be responsible for the data and for the object that we are looking for. So because this happens very far away from the querying node, it's very hard to verify. There are also several approaches how to attack and to address these attacks. What can also happen is that an attacker sends incorrect routing updates. So it tries to change the routing entries of the other nodes in order to cause damage to the routing in general. So it can pick bad nodes, it can be doing bad choices for the next hop, and this is one possible attack. And what can also happen, if there are various attackers in the network, they can try to partition the network. So they can try to identify weak nodes and strategically good sitting in well-placed nodes, and to try to remove them from the system, or to take over their position, so that at the end two parts of the network exist and messages cannot be passed from one part to another without passing the malicious nodes. So they get in a very relevant point, and they can partition the network. Also, there are some approaches that exist how this can be counteracted. Another approach that can be done by malicious nodes is a Sybil attack. So Sybil is referring to a schizophrenic woman who had multiple identities, and the idea is in networks that we might also have some nodes which have multiple identities and are occurring at many places in the network. And with that, one physical entity can have really more impact on the network than it would have otherwise. As a result, so it can attack a replication, for example, if it's responsible for many replicas and then it leaves the network, then all replicas at once are lost in the network and data might get lost. So this is more general. So if you have multiple identities, you can do also other things, like for example the eclipse attacks. That means that you have a conspiracy of malicious nodes, and they try to cooperate in order to remove good nodes or data from the network. So that's how do they do it? They try to circumvent and to have to be placed at strategic positions in the network, so that, for example, they separate one node from the network by being all of the contacts of that node, or data can be excluded from the network by placing the malicious nodes at positions where the data is looked up. So this can be also a severe attack. And for that, of course, you typically need several identities, which you can get with the Sybil attack. So, having a mini conclusion on structured P2P overlays, what do they provide? They provide ID-based routing. That's very useful. With Corda and Pastry, you can look up content based on its ID, and for that you use only the devices that belong to the user for storage, for routing, and of course with that user devices that being responsible, you also have several security challenges like routing attacks, routing table poisoning, Sybil and Eclipse attacks, and also replication can be attacked if the data is stored at multiple instances and attackers try to attack these copies. So several challenges arise in the area of peer-to-peer overlays. And this is also the point which is addressed in the seminar and which we will investigate. So which topics do we have? So first of all, there are three large areas: networking algorithms, where we have three topics which are very MUA related, so very theoretical. Then we have topic set number two, security and practical networks. There we look at practical issues in security, and both the section 1 and 2 are basically paperwork. And section 3, that's also practical, so also not related in MUA, but here we try to practically evaluate the impact of attacks in peer-to-peer networks in a simulator. That means that requires also to implement and to have a look at the simulator and to test the effects of these malicious behaviors in various overlays. Here 2 persons cooperate in a team in the section 3, and in the previous networking algorithms and security and practical networks 1 and 2, there only 1 person's work on a topic. Okay, let's go through the topics. So the structure is as following. I will present every topic in a slide, and also the first papers to read as a starting point. So the first topic is on coordinated consensus in dynamic networks, and papers from Fabian Kuhn and further authors have submitted and accepted by the POTC conference 2011, so very timely. And the paper is on consensus and how can it be found in dynamic networks, and what are the bounds for how fast this consensus can be made, how secure it is. So a consensus is an agreement of nodes on a specific topic, and it's really difficult if you have dynamic networks, if they're joining and leaving the nodes, and you try to come to a conclusion. And in this paper, the task is, in this seminar paper, to really dig into the paper, read through it, understand it, and describe it for us in your own words and present it. It's quite tough paper, a little bit theoretic, and so it's challenging, but it's also very nice once you went through it and you have it understood correctly. Okay, the next topic in this field of models and algorithms, MUA, so is Voila. That's a peer-to-peer application which is really had some success. So it's something like Dropbox, where you have a peer-to-peer based storage. It's also centralized elements are inside, and it's supporting quite strong and security and performance. And what should be done in this seminar paper is to analyze the publications on it that are available, and that's first of all Cryptree. It's a tree structure for holding data, and also Havala, which is a reputation system for peer-to-peer systems. And the question here is, because Voila is so commercially also successful, it's one of the highlights of the last years, and it's secure, but it's still unclear somehow how good the storage quality is, how well file availability is, how secure it is. So how many nodes can leave in a specific time interval, and the data is still online, and how is the number of nodes inflecting on the performance, how many data items have to be collected to be presented to the user depending on the user size and the data size. So many challenging questions on the security and the performance bounds should be addressed in the seminar paper. Okay, the last topic in the field of MUA is attacks on replication-based storage systems. So replication-based storage systems are quite have been quite popular in the peer-to-peer research, and there are several approaches. So first of all, this paper should give an overview on the approaches for replication. The most prominent top 2 or 3 should be selected, so which are very promising and very frequently used, and various attackers should be observed and modeled for this replication approaches. So you should try to find out what kind of attackers exist and what are the potential attacks for these top 2, let's say, approaches for replication, and then go through it and provide a model. So what's the minimum ratio of replication needed under the various attacks, and the churn, that means the online and offline behavior of the nodes, to reach a desired availability. So how high should the replication rate be in order to keep the data available with a specific probability? What is the influence of file sizes, of node online behavior, of attack strategies, and what is the effect on storage costs and retrieval costs and the performance? So there you should basically show which kind of replication approaches exist, what kind of attack models exist, how they interact, and what are the interdependencies of attack models on the replication models, and provide us with that knowledge and give us that models. And there are also 2 papers to start with. And the following topics that I will present are in the field of ESS, so they cannot be counted for MUA. So first of all, security in practical networks. That's the big topic. And 2.1, topic 2.1 is attacks on live social. What is live social? That's a peer-to-peer based online social network that has been developed since several years. And the idea is to really have some Facebook-like user experience, but fully peer-to-peer. There's also a project group going on currently, a peer-to-peer framework for social networks, which tries to find out how to best implement a social network on a peer-to-peer basis. And the questions covered in this seminar is to really have a look at the architecture of Live Social to see what is used, and to analyze and discuss weaknesses of the components used and their interaction. So what kind of attacks can be applied in free pass tree which is used, what kind of attacks can be applied in pass, that's the replication layer, on the security components, so how they be attacked. And it requires some strong knowledge in IT security, but it also offers you the opportunity to really test your knowledge and your security patterns and methods that you know on a clear example. Okay, another topic in the field of ESS is access controllers for distributed data structures in malicious networks. So that's a long title. What it means is we might have malicious networks, but we'll still want to have distributed data structures, and distributed data structures like a linked set or a set in general, which is distributedly stored. So not just a pointer operation or distributed hash table, which is more common, but it's really to have more advanced distributed data structures. And now, what is also required in this area is to have access control. That means you want to have a distributed data structure, to have read and access rights, and you have a network where malicious nodes exist. So how can this be done? So give an overview on research solutions and their applicability in pass tree. So have a look at research papers. So how can access control be implemented for distributed data structures? Classify them systematically, so given classification of the solutions, and apply an evaluation scheme on how good is it, how does it well fit to the overlay pass tree, and discuss what kind of solutions and challenges arise in this area of access controllers for distributed data structures in malicious networks. Okay, the last topic that can be covered by one person is on attacks on quality monitoring solutions in peer-to-peer systems. So what is that? So quality monitoring refers to gathering statistics on the peer-to-peer network. That means that you want to gather statistics, for example, on what is the average traffic consumption in the network by the nodes, what is the average lookup time, what is the number of messages sent and received by each node. So these are just statistics on the network, and there are two main approaches, either gossip-based or tree-based. So here you have the two figures for it. In gossip-based, you basically exchange with your neighbors somehow your current view. You calculate with your neighbors then the average, for example. In the next round you send around that average, and with time there's a convergence to the overall average, for example. Another approach is this. So one solution for it is, for example, this explained in this gossip-based computation of aggregate information paper. And another type of approach and solution is tree-based, where all of the nodes gather in a tree-based structure their view and their knowledge, and at the root, in the root, all of the knowledge is gathered and combined and sent then out to all nodes again. And as you see, the problem is if you have malicious nodes in the network, they can change the statistics, and with that falls in the overall statistic computation. And this paper should result, so the seminar paper should cover a systematic overview and discussion of the attacks approaches and security solutions for gathering statistics in peer-to-peer systems. So how can it be attacked in the gossip-based and tree-based approach? That will be probably easy. But what kind of solutions exist to hinder the attacker, or to detect the attacker that data is not corrupted and the statistics are not corrupted at the end? That should be discussed. Okay, the next large area for topics is evaluating the impact of attacks in peer-to-peer networks. So it's very practical, and here two persons are assigned to one topic. So when you make a choice which topic you would like to have, make sure that you also have a partner, or if you don't have one, I will try to assign one to you. But best would be if you assign with already in a team for one of these topics. And the topics are the following. So first of all, Sybil and Eclipse attacks in court. So here you should evaluate in Chord how an attacker might run a Sybil or Eclipse attack to, for example, to take out a single node from the network so that they cannot access it anymore, or to even take out data from the network to hide it from other nodes so that it cannot be accessed. That's basically what should be done in the first topic, to really practically test how it can be done and what kind of attack approach there is, and to see the effect. And all of these simulation-based topics will use the same simulator and test their approach then in the network with 1000 nodes. And then you can see, for example, in topic 3.1 how the Sybil and Eclipse attacks, for example, hide the data from all of these 1000 nodes, that it's really working. The second 3.2 is doing the same but in the overlay pastry, so there another kind of approach is required than in Chord, but still the goal is the same. Topic 3.3 is addressing routing attacks in pastry. So here it's analyzed how individual nodes in pastry can falsify and change and attack the routing, and how the effect of those nodes are. So for example, what happens if you have 10 or 20 or 30% of malicious nodes, how many messages are dropped, how many queries are lost, and that should be analyzed. 3.4 is covering the root table poisoning. So here the malicious nodes do not try to actively drop messages, but they, for example, try to change the routing tables of other nodes so that the queries get lost. And how big is the effect of 10%, 20%, 30% of the nodes, of malicious nodes in the network, if they try to apply a root table poisoning strategy. And the last one, 3.5, is considering replication attacks on the replication layer, also used in pastry. So the simulator also contains a replication implementation which can be run on top of pastry, and which makes sure that if data that is stored by some node, so it makes sure that the data is still available even if the nodes go offline, because previously the replication approach made sure that there are sufficient copies of the data in the network. The papers for this 5 topics are quite similar. So the Chord paper is the first one, so that's the main one to read. And if you're having a topic with pastry, then the pastry paper is relevant. For Sybil attacks, these 2 papers are relevant. For routing attacks in pastry, these 2 papers are relevant. Anyway, there's also good seminar paper from the last seminar, and I will put it online to see how such a seminar paper should look like at the end. It covered routing attacks in Chord. That's why it's also relevant for routing attacks in pastry, and for replication attacks, that this paper is also quite fitting. Okay, so what should be an outcome? And this is some example, especially from the paper of Tim Strothmann and Tobias Vibraniec, and I just show you the results. So their topic was, like it was said, routing attacks in Chord, and they analyzed through reading the corresponding papers 4 main strategies that a malicious node can run to attack the routing in Chord. I don't want to go in detail how it really works, but so just to have it that you have 4 attack types. And what they did, they set up experiments, and so first of all they implemented in the simulator, the Chord was already implemented, and they implemented this malicious behavior. And they analyzed the impact of different ratios of malicious nodes. They analyzed the impact of varying network sizes, so 1000 and 10,000 nodes, and several malicious behavioral strategies. And what they looked at is how does it take effect on the average number of hops per lookup, to look up data, and the ratio of failed lookups. And they run these simulations, and what came, for example, out is that you have that the average number of hops increases with specific message attack strategies, and of course the ratio of malicious nodes has also big influence on the average number of hops So the more malicious nodes you have, the bigger the impact is. And this could be also verified for 10,000 and 1,000 nodes. And if you look at how many messages and lookups went lost and were dropped over time, then you can also find out which attack strategy had which impact, and these are very nice results, both also with 4,000 and 10,000 nodes. Okay, so this is basically what should come out for simulation-based evaluation. And having a look at the seminar topics again. So the first three under the networking algorithms section is Moore related. So if you want to use the seminar in Moore field, and the other topics are basically ESS in the ESS modules. The first and the second sections are for one person each. So here we have 6 persons, and the third section is covering a simulation-based work as well. So that's why 2 persons should work in a team. So these 5 topics hold place for 10 people. Okay, how do we proceed? So I have a small overview on the simulator. There will be a longer lecture, especially on how to use the simulator. It's called pfxsim.com. I just want to show you a small snapshot of it, so that you get a feeling that it's really not too complicated to use. So first of all, what are simulations? Simulations help to evaluate the behavior of large-scale networks, and typically how do they work? So we have several nodes in the simulator. They all have their own state, and they communicate via commands and messages with each other, and trigger actions in each other. And there are 2 main types of simulations. So round-based simulation, where everything is happening in a round synchronously, so all at the same time. It only affects the next round. That's quite unrealistic. And what we use in our simulator, it's an event-based simulator, and we have a timeline of events, and every event has a specific time in which it's executed. It can of course also create further events in the future, and the time jumps from event to event, and it's progressing, and so every event can have effect on every other event. Nothing is happening at the same time. That's more realistic. Okay, and pfxsim.com, so there's basically 2 big research groups using it. First of all, one at the Technical University of Darmstadt, also in a research project considering peer-to-peer networks and quality of them. And the nice thing is that really many people worked on it, and it's quite usable and also user-friendly. It's event-based, it's written in Java, so that really many students can work on it and can simulate very large networks. For 1,000 and let's say 10,000 nodes are a good number, and it has very many layers that are supported, so that's why we can also place our malicious nodes or that kind of behavior easily in the simulator. So how does it look like? What you should take with you is that it's also layer based, so you have network transport layer, overlays where coordinate pastries inside, an application layer, and so on. Everybody can work on his or her own layer, and there are also nice examples in them. And the nice thing is that once you have implemented, for example, a new application, it can be also tested with different overlays, so you only have to work on one layer and the other layers can be modified and exchanged, and then you have a broader range in which you evaluate it. Okay, so just go quickly through which elements we have. We have an underlay. It's mainly responsible for defining latencies, how long it takes for a message to traverse from A to B. So these end-to-end connections, there are different ones based on simple models, but there are also more complex ones like the global network positioning layer, which is really based on measurements in the internet, on what kind of latencies there are, what kind of bandwidth there are, packet loss and all of it. So many quite good data that is used to really have proper distances and latencies in the network and the simulator. However, it will not be the focus in this seminar. What is more interesting is the set of overlays in the simulator. There are really lots of unstructured overlays, but also in distributed hash tables we have chord several times. There's also a pastry should be inside. It's not on the slide, but pastry is also implemented. So all of the overlays are already implemented. What is also implemented is on the service layer, for example, replication, a path that's linked to FreeBSD. Also monitoring is implemented, and some automatic control loop. But here for the seminar topic 3.5, the replication is more interesting. And what is also implemented are applications like the file sharing application with realistic file popularities, which are CIF distributed. Also a realistic transmission of these files once they have been found. There are distributed hash table lookup generators which just generate the load so that you can check whether your network's working properly. So everything is prepared basically. Just what is required is to implement, besides this normal behavior of the nodes in the application, the malicious behavior of the nodes, and to see what is the effect of it. Also, what is inside, lots of monitoring. That means to have logs and GNU plot output, so that it's really convenient to get statistics out of the simulator. And even for the overlays that represented chord and pastry and all of them, there's a unified monitoring output, and it's really nice to use. Of course, churn is inside, so the node go offline, online and offline according to realistic patterns, and there's also nice visualization. Okay, just what you should take out of it. There will be anyway a longer lecture for those of you who want to take a topic with a simulator. What you should know: quite a lot of things are implemented: file sharing application, chord, pastry, replication, attackers for chord. So for routing in chord, so you also have a good example how this can be done, for example for pastry. And what you have to do in the seminars basically to implement the malicious behavior, for which you already have an example in chord, and to see the effects. And there we have also a good example from the last seminar. Okay, literature I recommend is in general use Scholar, google.com if you look for further papers. Here are 4 books also on the right side. Here, given the link, you can also download the books. I recommend that one. That's quite my book, which is quite useful for the introduction in P2P networks. But I mean, if you find a good book, that's good. Okay. So what should you take as an outcome? What are the next steps? First of all, there's a website where you find all the information that are related to the seminar, so check it regularly. There's also Doodle for the topic selection. So what is required that you pick your topic. You can choose one green button in Doodle basically for your favorite, and 3 yellow ones for your also okay choices. And if you want to pick one of the simulator-based topics, then it would be good if you already sign up in a team. If you don't have a team partner, that's also okay. You can also sign up like this. I will make an assignment, or we will make an assignment and a group building in the next meeting. Next meeting will be also on 17th of April, and there will have already the matching for the Doodle-based choosing of seminar topics. Please make your Doodle selection, topic selection until the day before, so until the 16th of April. And on 17th will be the seminar topic assignment. EasyChair will be the conference management system, so for managing seminar papers. And I invited you all to become reviewers. That means program committee members. Please accept, and also register in EasyChair with your email addresses that you also have in Paul, so your university email addresses, so that the author role that you register for individually will be linked to the same person, the same email address like the reviewer role. And if you want to see further information on the simulator, as it was said, there will be a lecture on it, how it works. Visit the website pfac.org. And that's it for today. So if you have further questions regarding the seminar topics, just write me an email. I also put online the list of the seminar papers again. And so thank you very much for watching, and see you next week.